Today we are going to talk about the Newton's law of motion. There are total in 3 laws, and before I explain each of the law, I will show you a demonstration video to you. So make sure you have a basic idea in each law, and if you have any question, please ask me immediately, because these 3 laws are interacting and have a relation between them, okay? So let's talk about first law first, and let's look at this demonstration video.
球員，所以你哋要嚴肅認真，團結向上。
明白晒，踢波啊！你聽我講好唔好啊？你站喺我立場諗下，你會點啊？咁咪係咯。我有電話入等陣。咦，個波跌翻落嚟咯！喂，死落嚟啦！等你個幾鐘頭啊！等你個幾鐘頭啊！
哎呀，
踢波啊！
隻波響嗰邊啊！
So that is the demonstration video. So you can see that in the video, the ball is kicked hardly towards the sky, right? And just after a while, it falls back on the ground, right? So let us illustrate the events. Ball here, right? So it should be keep moving to the sky. Keep flying to the sky, right? But after a while, it just fall back. What is the reason that makes the ball fall back to the ground? Yes, can you just guess it? We are on the Earth. Yes, it's gravity, right? Gravity is the main factor that will make the ball fall to the ground. Also, there is atmosphere covering the Earth, right? So there's air, and air will have the air resistance, which will also affect the motion of the ball. So actually, if the whole event is happen in the space, the ball will keep on fly to the space with a constant speed and the same direction. We will call that the same velocity, right? The same velocity. But we live on the Earth, right? So there are 2 external force that will affect the motion of the ball. So what does the Newton first law told us is that actually an object will keep moving towards the same direction and the same speed unless other external force is exerted on it, or the object will stay stationary. That means it will not move. Okay, so that's why in space, if we just kick the ball so hardly, it will fly to the space and will not fall to the ground. Okay, so that's the first law. An object will remain stationary. So be careful of the spelling. If it's ARY, if ERY, it represents the pencils, rulers, and rubbers. That's stationary. It's different meaning, okay? Or in a uniform motion, which includes the same direction and same speed, okay? So it's easy to understand the first law should be, unless our net first acting on it. So understand here? Okay, so we move on to the second law. So let's just watch the video again. now let's get back to the notes. So what do you observe in the video? Yeah, the ball is kept the ball is kicked. Yeah, when the ball is kicked to the wall, it just bounces back in slower speed. So let's illustrate the event of the video. So there is a person who kicked the ball. A ball is here, and then the wall here, right? So according to Newton's first law, if there is no any obstacles or no any external force right here, will the ball move back to the sorcerer? No. Yes, it should be no. It will move. You will continue to move forward with the constant speed. Okay, but here there is a wall right here. Yes, so the wall will just stop the ball and then make it move slowly to the foot. So let me use the blue line to indicate it. So the ball, originally the ball is accept the force from the foot. So the arrow here, the foot just exert the force to the ball. And remember, there is always an object. There's always an object to accept the force. Right here is the ball accept the force from the foot, so it's move in a very high speed to the wall. And then when the ball hits the wall, it will bounce back slowly to the foot. And again, when the ball arrives at the foot, the sorcerer kick the ball very hardly and will move fast to the wall again. Just a continual practice. You can see from the video, right? So here, just consider the movement of the ball. What will affect the movement of the ball here? What will affect the ball movement? Okay, you think the mass. So yes, also it depends on how hard the sorcerer kicked the ball, right? So I will say that it is a net force. So here we use the term net force, not just force. Why was the reason? Because here we just account the force that only happens between these two objects. Here is the foot and here is the ball, right? We have excluded any external things, like just we have mentioned, like gravity, air resistance. We assume that there's nothing, no air, no water, no any resistance that will affect the motion of the foot and the ball. So this is the assumption. You can write it down. Assume no any external force. Okay, so we use the term net force to explain the case here. So let me go back to these two things, the mass and the net force. Just what I've mentioned, when the ball arrives the foot, it will move much more faster, right? It means that the ball is accelerated. So we also use acceleration here. So what is the relationship between acceleration and these two things? That is, yes, so just consider if the ball is heavier, will it move faster or slower? It should be slower, right? So we will say that acceleration and mass is at inversely proportional. We will write it and represent it in this way. So how about the net force? It means the force we exerted on the ball. Yeah, you can just imagine if we kick the balls so hard, it will move much more faster, right? So each is directly proportional. So when you combine these two relationships, we will get this formula, F equal to ma. And I think you should have heard or seen this equation before. And this equation is the Newton's second law. So this second law tells us that the force depends on the mass and the acceleration, and the force will change the speed and the direction of the movement of the object. So here we let's draw the conclusion here. The acceleration of an object is in the same or opposite direction as the net force acting on it. It should be directly proportional to the net force and is inversely proportional to the object's mass. Okay, so that is the second law. Any questions here? So if no, then we'll move on to the third law. Okay, before the explanation, let's see the video.
安睡褲都可以乾爽透氣。Whisper 革新紅袍安睡褲，突破性迅級散熱芯，更輕薄、更散熱，貼團貼縫，舒適更防流。革新紅袍安睡家族。
飛你老母啊！
Okay, so this is the third video. So what do you observe in this video? Yes, you can see that there's a can that's to be kicked, and then the can is stuck on the wall, and then when the can is removed, the wall collapsed, right? So let's illustrate these two events in the space here. So first, the can is kicked. So we draw foot here and a can here. You just sketch it briefly. Do not need to draw details. Okay, that's the can, and then it's stuck on the wall, right? Okay, so that's the two situations that demonstrated in the video. So let's talk about the kicking of the can first. So yeah, the can accept the force from where? Yes, from the foot, because we kick it, right? So just draw an arrow here. So remember that what I've mentioned, there's always an object that accepts the force. Otherwise, this free law will not be valid, okay? So when the foot kicks the can, and the can just arrive to the wall and you're stuck here, and then the can accept the force from the kick, from your foot, from the foot, right? So the can have the force, and then when it arrives the wall, it exerts the force on the wall. So here is where the arrows are drawn. Can you draw it here first using the blue lines? Yes, the arrow should on the can and then pointing towards the wall. And then, but at the same time, when the can hits the wall, there are some cracks here. Right, cracks. It means that the wall actually is broken because the force is so hard. So, actually, it's also evidence that show that the can has exerted the force on the wall, right? So at the same time, why the can will not fall down? Or because, yes, you have pointed out the point, because the wall also exerted the same amount of force to the can, so that the can will stand still right there and it will not fall down on the ground or just drop it behind the wall, right? It will not fall down or drop beside, will not, because there is a reaction force acting on the can also. So when the can is removed, the wall will collapse, right? So the same as this case. When we kick the can, okay, so our leg is the passive or the active side. The leg is the active side, right? So we leg exert the action force to the can, and then the can is the passive, right? So the can will exert the reaction force to the foot also. So just same as here. So the wall in this case, the can or the wall is the active side. Yes, in this case, the can is turned to the active side, so the can exerts the action force to the wall, and the wall is the passive side, so the wall will exert the reaction force to the can. So be reminded that when you draw this diagram, make sure that the size of the arrow should be the same, because it just represents that the amount of force of action and reaction are equal. Bear in mind that, okay? They should be the same. Okay, so let us conclude the third law. Force always exists in pairs which are equal but in opposite directions, right? Yeah. Just remember the can and the wall and the foot and the can. The action force and the reaction force act on different interacting objects. Yeah, they will not happen on the same objects. They will act on different interacting objects simultaneously. So that's the 3 Newton's law of motion. So you can see that actually there are a lot of things around us that are that are valid the Newton's law of motion. Just be careful and be aware that everything surrounded you, and try to explain them with the law that you have learned today. So that's all for today's lesson. Thank you.